All right, this is Tech Math 2, and we're in section 6-7. And the question is, the first question is, the answer is 1/2. What's the problem? Okay. Right, what's the problem?
1/2 plus 0.
Okay, 1/2 plus 0. Okay, that'd be 1/2 plus 0. Okay, the answer is 3/4. What's the problem? Right, what's the problem? All right, I'll give you 4 4s minus 1/4. All right, there we go. I got the problem. All right, so that's what we're doing. We're gonna have the answer, and we're going to break it up into what we call partial fractions and find out what the problem was. All the rest of the time we came up with the problem, right? So it's a 4 over 3x plus 2 plus 5 over 2x minus 5. And then we say, okay, well, we have a common denominator, 3x plus 2 times 2x minus 5. And on the top we have 8x minus 20 plus 15x plus 10. And now I got a final answer of 23x minus 10 divided by 3x plus 2 over 3x minus 5. Okay, so we've done that before, right? But now we're going to go the other way. We're going to say, okay, well, I got 3x minus 10 divided by 6x squared minus 11x minus 10. And I want to know what did I add to get that? Okay, I want to know, I added something. I added something plus something, and I got this. And now I want to find the something plus something. All right, well, I go back and say, well, what does this factor as? Well, it factors as 3x, let's see, 3x plus 2 and 2x minus 5. And then I check that and say, well, that's 6x squared. That's minus 15 plus 4 makes the 11. Okay, so that's good. Over 3x minus 10. And I'd say, well, that's going to come up with something, I don't know what it is, over 3x plus 2 plus something, I don't know what it is, over 2x minus 5. Now, this something that's on top is always a degree less than the something on the bottom. So if the something on the bottom was x squared plus 2, then the something on top would have to be ax plus b. Okay, so I'm a degree less. All right, so that's just one of those things. All right, now this has to equal that guy there. Okay, well that's fine. We can do that. So now I'm gonna find my common denominator, and then on top I'm gonna have a times 2x minus 5 plus minus b times 3x plus 2, and that's going to have to equal what's on top, 3x minus 10. Okay, so when I find my common denominator, it's that guy times this guy. When I can't take this times a, that times b, but when I get done, I have to be what's on top. All right, well, okay, that's fine. So now I've got 2ax minus 5a minus 3ax minus 2b is equal to 3x minus 10. I've got 2a minus 3b x plus, or it might be a minus, I'm not sure, minus 5a minus 2b has to equal 3x minus 10. All right. So I look at that for a little while and I say, well, 3x has to be over here because there's no x over there. So that means 2a minus 3b has to be 3. And it means that 5a minus 2b has to be minus 10. Now what do I have? Now I have two equations, two unknowns. And I'm in chapter 6. So that's why partial fractions end up in chapter 6, because it's just a funny way to come up, to make you come up with two equations, two unknowns to have you solve the problem. Okay, so that being the case, we'll use Cramer's rule and we'll say we'll say A. A is equal to 3 minus 10 minus 3 minus 2 divided by 2 minus 3 minus 5 minus 2. Determine it out. I've got minus 6. I've got plus. I got minus 6. I got minus 30. I do? Minus 6 minus 30? Yeah, that's what I got. Minus 6 minus 30 for a minus 36. I've got minus 4 minus 15 for a minus 19. Minus 19. Well, that's hard to believe because it's supposed to be a 3. So what did I do wrong? How could I have made a mistake already? 2ax minus 5a, 3bx plus. So that's a plus sign. That's a plus sign. That's a plus sign. That's a plus sign. Where's the plus sign? Right there, and right there. All right, well, that was professional, if I ever see anything professional. Okay, so I got 6 minus 30 for minus 24. And I've got 4 minus 15, 4 minus 15 for minus 11. I'm still not getting 3. I got 6 minus 30. That is minus 30, right? Minus 30, 24. I'm supposed to be getting an 8. 2 minus 5 minus 3, 2. 4 minus 15. Where's my next mistake? So I've got A times that guy. I have a 3 here. Why do I have a 3 there for? It's not a 3, is it? It's really a... So I got 4, 8, 4, minus 20, 3, 15, 2, 10, minus 10, 15, and 8 is what? 23. All right, so that's what I got. Oh. Um, 23x minus 10. Way to go, Doug. See that 23 up there? Yeah, 23x. All right, there we go. All right, so now that's 23. That's 23. This is 23. I think we ought to just throw the whole video away and start over from the beginning. All right, so where were we? This is 23. And, okay, so minus 11's right. But this is 46 minus 30 is 16. Now we got a negative number on the bottom. I'll start with problem number 1. There's a time where you just should give up on a problem and move on. Ben knows that, right, Ben?
All the time.
Yeah, long time ago. All right, so we'll start with problem number 1 and see if we can just get the homework done today and then call it a day. Minus 29 over x plus 2, x minus 7. And now we'll try to pay slightly more attention to detail. All right, so this is going to be x plus 2 over a plus x minus 7 over b over that. And I'm going to find a common denominator, and it's going to be x plus 2, x minus 7. And when I'm doing that, I'm going to have a x minus 7a and a bx plus 2b. And that has to equal what's on top. So that being the case, the bottoms are the same, so the tops have to be the same. A plus b x plus minus 7a plus 2b has to equal 8x minus 29. All right, that being the case, a plus b has to equal 8, and minus 7a plus 2b has to equal minus 29. I have 2 equations and 2 unknowns. The right thing to do would be put it in my calculator and tell me what the answer is. But I'm going to go and do Cramer's rule. 1 minus 7, 1, 2. So on the bottom I have 2 minus a minus 7 makes it a 9. What is that? Well, how come I got 2 lines there? So I got a 9 on the bottom. 8 minus 29, 1, 2. Okay, so 16 plus 29 is 16 plus 29, 30, 45. 45, A is a 5. And then what's B? B is going to be divided by 9 because that didn't change. And on the top I got 1 minus 7, 8 minus 29. And I'm going to have a 9 divided by, and I'm going to have a positive guy up there again. So I've got 8 times 7 minus 29 is a 27. So B is going to be a 3. So I'm going to have a 5 divided by and a 3 divided by. And my original problem was x plus 2. X minus 7. And so that would be my final answer. And then we'd want to check our work. So we'd check our work and say, well, this is 5x minus 35 plus 3x plus 6 divided by x plus 2, x minus 7. And then I'd say, well, that's 8x, that's minus 29 over the stuff that's on the bottom. And that's exactly what we started with there. So using the author's problem instead of the instructor's problem, we got one right. But the reason partial fractions are in this chapter is so that we can solve 2 equations and 2 unknowns without giving you those equations outright. You have to figure out what they are. All right, number 9. Oh, bummer. 4, 8, x squared minus 20x minus 5 over 4x minus 1 cubed. Now, your first indication is that, gee, I should make this 4x minus 1 over something plus something over 4x minus 1. plus something over 4x minus 1. Unfortunately, if you did that, you'd get the wrong answer, so you can't do that. All right, so there's some theory here, and it says where is the theory? Repeated linear denominator factors. So on page 246, it says that we need to write this down different. That we need to look at this as a over 4x minus 1 plus b over 4x minus 1 squared plus c over 4x minus 1 cubed. That is how it's going to factor out. Well, that becomes a horse of a different color and becomes a pain, but that's okay. We'll just one of those things. Okay, so that being the case, we need a common denominator again. So the common denominator is 4x minus 1 cubed. In order to get that, we're going to have a times 4x minus 1 squared plus b times 4x minus 1 plus c. And then we're going to expand that as 16ax minus 8ax plus a plus 4bx minus b plus c divided by my 4x minus 1 cubed. And that's good. So the top is going to equal, what's it going to equal? What problem are we doing anyway? Number 9. So 48x squared minus 20x minus 5 has to equal 16x squared. That's the only x squared guy. Plus minus 8a plus b x. Okay, so that's this guy and this guy. Plus a minus b plus c. All right, so that means that 48 has to equal 48. Where is my a? 48 has to equal 16a. All right, so 48 equals 16a, implying that a is equal to 3. All right, so I got that one. And then minus 20 has to equal minus 8a plus b. And I already know that a is 3. So minus 24 plus b, implying that b has to be 4. And then the last guy, minus 5, has to equal a minus b plus c. Okay, I already know a. I already know b. Plus c has to equal minus 5, implying that c is equal to 4. No, 4, 5, 6, 5, 6, 7. I don't know. C is equal to 12. What is going on? Huh? Someone tell me what C is. Is it 5? No, it's not 5. Huh? It's minus 4. Yeah, minus 4. Okay, so C is minus 4. There we go. We got it. Figured it out. I knew it. What? Right? 3.
Yeah,
3
4.
minus 8 is minus 5.
Where'd you get A?
Well, if C is minus 4, then minus 4 is minus 8. 3 minus 4 is minus 5, and everything is fine. So if minus 5 is equal to 3 minus 8, then C has to be equal to minus 4. No? All right, we'll try it again. Do it
What did you
in
get for B?
minus. Oh, B was 4.
You can't see those 4.
What's going on?
Zoomed in.
View, zoom, 150. Does that help? Yeah, why didn't you tell me that before? Anyway, don't worry about it. So now are we happy?
Yes.
Minus 5 has to equal to 3 minus 4 plus C. The 3 goes on the other side of the equation. Minus 8 is equal to minus 4 plus C. The 4 goes on the other side. Minus 4 equal to C. Okay, now we can write down our final answer. Final answer. All right, so we've got 3, 4, minus 4. Okay, so I got 3, I got 4, I got minus 4. And if we knew what the problem was, we'd know what to put down here. 4x minus 1, 4x minus 1 squared, 4x minus 1 cubed, plus, minus, get rid of that minus there. Okay, final answer. Must be true. And it's 9, it's in the back of the book, so we should have been able to check it. All right. So is this fun? You've never seen anything like this in your life, did you? Isn't this great? Now, when was the last time you wanted to take a math class and you only did what you already did? You know, really, give me a break, man. All right. So 29. I've got, wow, how do I do this one? 3x to the 4th minus 2x cubed minus 2x plus 5 divided by x squared plus 1. Now, in everything we've done so far, we've always said the guy on top is a lesser order than the guy on the bottom. Now I got the guy on the top, the higher order, so now I'm rather hosed. So, that being the case, I wonder what it is I'm going to do. Okay, so I got it. I'm looking on page 250 and I'm remembering what the heck it is I'm supposed to do. All right, so I'm going to change this and say x cubed plus x, and I'm going to divide into 3x to the 4th minus 2x cubed minus 2x plus 5. And I'm going to make this look more like a power instead of a 4 like it was. Okay, so this is going to go in there in 3x times. Okay, so I've got 3x to the 4th plus 3x squared, 3x squared, 3x squared. All right, so that looks kind of weird. So I'm going to subtract, and this goes away. And I have minus 2x cubed minus 3x squared minus 2x plus 5. And that's going to go into there minus 2 times minus 2x cubed minus 2x x. And then I'm going to have, I subtract to get 0, subtract to get 0, minus 3x squared plus 5 is my remainder. Remainder minus 3x squared plus 5. So my answer is going to look like 3x minus 2 minus 3x squared plus 5 over x squared plus x cubed plus x. All right, so now I've got, this guy's not a fraction, but he's a fraction, and that guy's a fraction. Now I have something with lesser order on the top than I do on the bottom. Now I can do my partial fraction guy on him. All right, so that's what I'm going to do, and I'm going to say I've got x squared plus 1, and I've got an ax plus b on top, and then I've got a c over x. And now I'm going to have to figure out what a, b, and c are. All right, so finding a common denominator, have ax squared plus bx plus c over x squared plus 1. No, I don't. X squared plus c. No, I do. All right, and then that's going to equal my common denominator, x cubed plus 3. And I need a minus 3x squared minus 5 on the top. Okay, well, that being the case, I look at the x squared term, and I see that a plus c has to equal minus 3. I look at the x term, and I see that b has to equal 0. There is no x term. And I look at the unit term, and I see that c has to equal 5. Okay, so I'm going to come and say c is equal to 5, and then from that I'm going to come to the conclusion that a had better equal minus 8. So I have a is minus 8, c is 5, b is 0, and now I can write my final answer. My final answer is going to be 3x minus 2 plus minus 8x over x squared plus 1 plus 5 over x. And that would be my final answer. And it's 29, so that means we can check the back of the book and see that it's right. And Ben's already done that, and he's shaking his head yes, that you got it right again. You're a brilliant instructor, you. Of course, he doesn't have his book open yet. He's just shaking his head, trying to make brownie points in the back row. But probably, I would imagine that's the right answer. But it might not be. We may have to correct it. Who knows? So what do you get? 29. There, thumbs up from the back row. So we've taken most of what we know from what we've done so far and thrown it into one section. I got to factor it. I got to find a common denominator. I've got to multiply it. I have to have multiple equations, multiple unknowns. I got to solve for the multiple unknowns. So all I got to do is put one of these problems on any test, and now you demonstrated every skill that we have so far. Isn't that cool? Yeah, pretty nice.
I expect the one question test.
Yeah, one question test. Well, I have 4 minutes. Anybody think I can do number? Anybody think I can do? Anybody think I can do number 22 in the 4 minutes of the class remaining? Okay, how many think I can do that? Yes? Do I hear a yes? And the answer is yes, I can. Watch very carefully. There's nothing up my sleeve. Oh, you're checking my sleeve already, I can tell. Nothing up my sleeve. And now it's a race. It's a race to come up with, with how to do it, partial fractions. Partial fractions. And you can't see that because we're doing it someplace. So, oh, okay, partial fraction. And did I misspell partial? You can't tell.
Yeah, there's a C where there should be.
Well, I got it misspelled. There's a T.
E-R.
Yeah, I'm running out of time. P-A-R-T. I have a C, and I shouldn't have that C. All right, so I got rid of the C. All right, partial fractions. All right, there we go. One set, convert, do something. All right, there we go. I'm not going to make it, I can tell. Oh, there we go. Convert that to partial fractions. Okay, that's what I'm going to do. Boom. Control, copy, back to the original one. So now it's a race to see whether or not I can type in the equation in time. Okay, so it's number 20. Oh, I got to get to 22 quick. Now on 22. Okay, so I got 3 times x to the 5th plus x raised to the 4th plus 24 times x raised to the cube plus 10 x squared plus 48x plus 16, close parentheses, divided by, ooh, bummer, parentheses, divided by, oh, why are we doing that? Okay, space, 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 there we go. Divided by x squared times parentheses x squared plus 4 close parentheses raised to the 2nd. Am I going to make it?
You got a minute.
Close parentheses, enter. Oh, there it is, yes. Did I put it in right? All right. Obviously, Maple doesn't like this problem very well because they gave us a weird answer. But there, I did it. And I had plenty of time to spare. Let's check my watch, see if I made it in time. What alpha? Quit making waves over there. The class was over a minute ago. And it's telling us the right answer. We just have to figure out what it means, you know.
Question and answer. The question you get those two right now.